By the end of this video series, you will be able to solve this problem on your own. This is part 2, partial fraction decomposition. If you can do these on your own, feel free to skip this video. But we're going to be building on part 1, so make sure that you're solid on these. Okay, so what do A and B need to be equal to? Well, what's the first step when adding fractions? You need to get a common denominator. So it's going to be x minus 4 times x plus 3. Okay, what goes over here? We multiplied by x plus 3 on the bottom, so we need to multiply by x plus 3 on top. What goes over here? We multiplied by x minus 4 on the bottom, so we need to multiply by x minus 4 on the top. What's the next step with adding fractions? Since this matches with this, we can do this plus this on top. Okay, so this is equal to okay. So this is the same thing as this, which is equal to this. Okay, so I can set this equal to this as well. Okay, so we've got that this fraction is equal to this fraction. Since this matches with this also has to match with this. Okay, so we've reduced the problem into asking, what do A and B need to be such that regardless of whatever I plug in for x into this equation, it always holds true? So how do we figure out A and B? Well, one strategy would be to turn this into 0. Why? Okay, so first, how do we turn this into 0? If this is equal to 0, what does x have to be? Okay. So I'm going to plug in -3 into this equation. Okay, so why are we making this 0 again? Well, the reason is because if we turn this into 0, then this is going to turn into 0. So we're left with a much simpler equation. We can figure out b is 5 pretty quickly. Okay, so to figure out b, we had to change this to 0. What do you think we need to change to 0 to figure out a? Change this to 0. Okay, so if this is equal to 0, what does x have to be? Okay, so x has to be 4, and I'll give you a second to pause the video and figure out what a is on your own. Okay, what did you get? Okay, so A has to be 3 and B has to be 5. How does partial fraction decomposition help us solve integrals like these? Well, with partial fraction decomposition, we broke down a difficult fraction into two simpler fractions. Similarly, we're going to break down a difficult integral into two simpler integrals. And you'll use what you learned in this video to figure out what goes here and here. But for now, let's practice. Because to solve that integral, we're going to build on ideas from this video. Okay, so to summarize, step 1 is to get something that looks like this. Okay, so that's step 1. What was step 2? Step 2 is to set this and this equal to 0. So if this is 0, x would have to be how much? -3. And if this is 0, what would x have to be? Try finishing this on your own. I'll include the full solution in the comments.